Okay, so we are looking at the concept of vectors. We're not going to get super deep into them, but it's something that you'll see in a physics class and maybe in some other classes, so it's a good idea for us to get an introduction somewhere here where you're in elementary functions. So our basic definition of a vector is that it's a directed line segment. That's a little bit less abstract than what I would like to give you, but it's the easiest thing for us to see. So I'm going to make just a brief sketch here of a couple of vectors, and I want you all to see what's going on, and we'll think of them in terms of coordinates. So the x and y axes that I've drawn there, I'm assuming that each of the tick marks is 1 unit long. I'm trying to get them as close to scale as I can. So if we had a vector that went from the origin to this point here at 2, 1, we might refer to the origin as O and that point there as P, and then we would denote the vector, OP vector, by saying it moves 2 units to the left and 1 unit up. And then if I were to similarly put something else here, where I've got, let's say, Q and R for points, and that point Q, hopefully you can eyeball that and see that that is the point 2, 3, and that point R, you can eyeball that one and see that that is going to be 4, 4. And the motion that takes you from point Q to point R is going to be 2 units to the left, 2 units to the right, and 1 unit up. If those had been to the left, it would be negative, or down it would be negative in the y direction. So the thing I want you to see is that because the entries of OP and QR are the same, and then those two vectors are the same motion, so they're the same vector. So think about vectors in terms of motion, and it explains a lot of the intuition here. Okay. Other pieces of definition here, instead of putting 2 points, sometimes you will just put a single letter like U or V, put a vector over it, and then have a couple of numbers there. Bear in mind, in higher dimensions, you might have 3 or 4 entries in there because you have a higher number of coordinates. This note here that we have I to be the, that did not point at all, I to be this 1, 0, and J to be the 0, 1, then suggests that we could also take this and say that it is 3 times the I vector minus 4 times the J vector. And that's just a different notation, but it all works the same. So then if I ask you to take the magnitude of this U vector that I just wrote there, then you would take a square root. You need to take the 3 squared plus the negative 4 squared. And so that's going to turn out to be the square root of 9 plus 16, which is the square root of 25, or 5. So most of the time you're going to get something that's not quite as pretty for the answer. Like if we looked at the OP there, we'd have 2 squared and 1 squared, and end up with the square root of 5, and that's not a really nice number, so we just leave it as a square root of 5. Then finally here, I'll say something about these angles that we've got, and I will talk about a vector where we can pick out the angle fairly easily. So I'm going to make this vector be negative 4, 4. And I'm going to draw a quick sketch over here, and we can see that if we put it where the initial point is at the origin and the ending point is here at negative 4, 4, kind of like putting an angle into standard position, then the angle that we need to have out there is going to be 135 degrees. Or if you're doing things with radians, you would say 3 pi over 4. But so, how we can figure out what the magnitude of this is, the square root of, now when you square a negative, you know you always get a positive. So I will lots of times just not bother to copy my negative across there when I'm squaring them. But in doing that, you'll end up with 4 square roots of 2. And then if you factored that out of this vector here, and I am realizing that I should not have put an equals there, but if you are factoring that out, then what you'll be left with is negative 1 over the square root of 2, 1 over the square root of 2. And if you go back and check, those are the cosine and the sine, respectively, of 135 degrees.